this video, I'm going to show you how to set up a linear programming problem using Excel Solver. Let's return back to our Wood Products Inc. and set it up as an LP problem. If you remember, Wood Products Inc. makes two products. They make tables and desks. They produce these products using a two-stage process designated as Department 1 and Department 2. In Department 1, the raw lumber is processed into pieces of wood that can be used for either product. In Department 2, the tables and desks are assembled. Therefore, every product must go through both departments. The products are sold at a profit of $1 for each table and $2 for each desk. In Department 1, it takes 2 hours to process the wood for a table and 3 hours to process the wood for a desk. In Department 2, they use 5 hours to make a table and 2 hours to make a desk. In this production period, Department 1 has 12 available hours and Department 2 has 15 available hours. The question is, how many tables and desks should be produced in this production period to maximize profit? First, we have to look at the decision variables, the objective functions, and then the constraints. So let T be the number of tables to be produced and D the number of desks. What's the objective function? Max profit, max P equals T plus 2D. What are the constraints? This is subject to 2T plus 3D is less than or equal to 12 hours. And Department 2 is 5T plus 2D is less than or equal to 15 hours. And T and D have to be greater than or equal to 0. So here's our standard LP form for the tables and desks problem. So how would we use Microsoft Solver to compute the max profit for this problem? First, let's open up Microsoft Excel. Then let's put together a basic setup for an LP problem. So what are the things that we already know? Well, we know what the profit is for both tables and desks. So the profit for every table we make is $1. The profit for every desk we make is $2. What we don't know is actually how many tables or desks we should produce. So I'm going to just keep these cells blank right now. And another thing that we know is that we want to maximize profit, but we don't know the value of our objective function. So here we're going to put in a formula, and we're going to say equals, and we're going to multiply the production amount of tables times the profit per table plus the production amount for desks times the profit per desk. Okay, and that cell will be updated once we implement the Microsoft Excel Solver algorithm. Next, what are our constraints? Well, we only have a certain number of available hours in Department 1 and Department 2. So why don't we create a cell called Department 1, another one called Department 2, and remember how many hours it takes to produce a table in Department 1, and that's 2 hours. How many hours does it take to produce a desk in Department 1? That's going to be 3 hours. And in Department 2, it takes 5 hours to produce a table and 2 hours to produce a desk. Now, let's go ahead and note the available hours that we have in each department. So in Department 1, we have less than or equal to 12 hours. So we have 12 available hours. That's our max hours. And in Department number 2, we have 15 hours available. And so in these cells, what we want to know is how many hours will be used in order to maximize our profit. So therefore, we need to put a formula in. And so the formula is very simple. It just equals, and the number of hours it takes to make a desk in department 1 times whatever that optimal production amount is to maximize profit, plus the number of hours it takes to make a desk in department number 1 times the optimal production amount for desks. Okay, and so right now that's going to be 0 because these production amounts, of course, are going to be computed by our simplex algorithm. Next, let's do the same thing for department 2. So again, we say equals the number of hours it takes to produce a table in department 2 times the production plus the number of hours it takes to produce a desk in department 2 times that optimal production amount. And right now it's going to be 0. So this is your basic setup for your linear programming problem. Now it's time to use solver to obtain our solution. Now we can run solver to obtain our answer. How do we do this? First, we go to the Tools menu. We select Solver. You'll notice this brings a dialog box up. And the first parameter that we need to enter is one that says Set Objective. This should be clear. This is going to be the value of the objective function. And here we're going to just go to cell I1. Next, we maximize profit by changing which cells. We're going to change the cells in terms of the production. Because again, our question is how many tables and desks should we make in order to maximize profit? Great. And that's subject to a series of constraints. So our first constraint is the number of available hours in department 1. So we have to add that constraint as a solver parameter. And we do that by pressing Add. And then what cell are we referencing? Well, first, we're referencing this cell, D4. And we're saying D4 has to be less than or equal to, as noted here, to 12, which is our constraint. So let's choose that cell, F4. Then we're going to add that constraint as a parameter. We have to add one more constraint, which is the number of available hours in department number 2. And so the cell reference that we put in here is D5. So D5 is less than or equal to 15. 15 is our constraint. Let's click in this field and select cell F5. Then we can say OK. And now we've set up most of our solver parameters. The next important step is to make sure that the unconstrained variables are non-negative. So we click on that, and then we choose a solving method that is the simplex LP, or simplex linear programming solving method. Then we click on Solve. You'll get another dialog box that says Solver Results, and click on Answer and Sensitivity for reports, because we want to see the answer in addition to the sensitivity analysis. Then just click on OK. And at this point, you'll see the answer, where we have a max profit of $8, and we'll see the available hours in department 1 that were used and the available hours in department 2 that were used that satisfy the constraints. We also see how many tables, 0, and desks that we should produce. Now this answer can be shown in the answer report 1 here. So you'll see that the max profit final value is $8, and you'll also see that the production of tables is 0, but the production of desks is 4. Finally, you can look at the sensitivity report for sensitivity analysis. I hope this demonstration of solver was helpful. Thank you.